Okay, right. Okay, so last class. What is the last class, guys? Up to B tree indexes. Yes. Uh, so the second index takes adding. So bitmap index. Okay, right. Your bitmap index. So bitmap index is okay. When and how to create it? Here observed. Bitmap indexes are basically we created on low cardinality of columns. Low cardinality columns. Okay, now now. So here, what is cardinality? What is cardinality? So here observe. So bitmap indexes, we said we created on low cardinality columns. Then the point is, what is cardinality means? Here observe. Cardinality is nothing but, guys. Okay, is nothing but unique. Okay, unique values of a column. So cardinality is nothing but refers unique values of a column. In a particular column, okay, how many unique values are there? Based on that unique values only, we can calculate a cardinality of a column. Okay, so how it was calculated cardinality of so and so column means, okay, the formula, okay, what is the formula for this cardinality to find out here means, so cardinality of column is equals to, okay, number of distinct values, number of distinct values of a column by number of cardinality is equals to number of distinct values of a column by number of rows in a table. Number of rows in a table. So this is my formula, guys. Okay, so here bitmap indexes are created on low cardinality of columns. low cardinality of columns. And what is cardinality means? Cardinality is nothing but, okay, unique values of a column. Unique values of a column. Okay, so that means in a column, how many unique values are there? Based on unique values only, we are finding cardinality. Okay, so of that particular column. And what is your formula for this? Means cardinality of column is equals to number of distinct values of a column by number of rows in a table. Okay, for example, let me see how to calculate my cardinality of columns here. Observe. For example, the definition we taken out here. I'll come back to your database. So our username is MyDB11am now. What is the password? The outside, call them. Nani system నాదేనా? నాది కాదు. ఏది అసలు వీళ్ళు పేరే లేదు. MyDB11am student. So before you want to create your bitmap index on this table columns, okay, what we said, bitmap indexes are created here, low cardinality columns. And cardinality means what I said, it refers uniqueness of a column, how many unique values are there, so which contains under a particular column. That uniqueness was telling us cardinality. Okay, now for example, if I need to find out any column cardinality here, if you want to find out here, so how I can find out? For example, EMP number is there. Suppose I want to know, so what about the cardinality of EMP number? So whenever you need to find out the EMP number column cardinality, so how we can find out the cardinalities means the formula. What is our formula, guys, here? Okay, number of distinct values of column by number of rows. Okay, for example, suppose I need to find out here cardinality of EMP number column is equals to, in this column, can you find out here number of distinct values? How many distinct values are there in this? Find out distinct values. How many distinct values in this column? 14, because each and every number is a unique number. So 14 distinct values. So distinct values means no duplicates. Okay, now, so distinct values here. So now 14 distinct values. Okay, that means number of distinct values 14 by number of rows in a table. Okay, how many rows in my table? 14 rows. Now you just go to give it 14 by 14 is equals to how much? 1. So that means the cardinality of EMP number column, how much here? 1. Understand now? Right. Now in the same to same, for example, another column. So cardinality of, okay, job column I want to find out. Suppose if I want to find out cardinality of job column, then tell me number of distinct values. How many distinct values are there in this? In job column, how many distinct values are there? Huh? Distinct values, guys. I'm asking distinct values. Distinct values means what? Duplicates, sir? No duplicates, sir. No duplicates. No duplicates means how many are there? One is clerk is one, salesman is one, manager is one, analyst is one, president is one. The total how many distinct values? 5. So 5 by number of rows. Number of rows how many? 14 rows. Now calculate here. So 5 by 14 rows. How much here? So 0.35. Okay, 0.356 something will come. Okay. So this is cardinality of your job. So now tell me, in EMP number and job column, in this two column, which column cardinality is low? Low cardinality, job. So that means my priority to create bitmap index on which type of columns I said? Low cardinality of columns. Okay, so now when I'm taking these two columns, okay, in these two columns, low cardinality is which column? Job column. So that means my priority when you want to create your bitmap index, okay, I can create on which column? Job column. So like this, you need to find out that column cardinality will find out, and based on that, if it is one less than, it means low cardinality. One or one greater than, it means high cardinalities. So now here one less than, okay, the cardinality 1 and one less than always preferred. Okay, which cardinality means, sorry, which index means bitmap index will be preferred by people. If greater than or equals to 1 cardinality, then prefer what? Here B-tree index will be preferred by industry people. Okay, so when your cardinality which is less than to 1, then priority should be bitmap. So they're giving priority which index what they want to create means they created bitmap. Suppose your cardinality which is equals to 1 or more than 1, then they will created what now? B-tree indexes. Why, sir? Why means when cardinality will less than 1, if I created B-tree indexes, my performance will be slow. The performance wise B-tree index will be give low performance. So that is the reason less than 1 cardinality always prefer bitmap, because bitmap will give a less than 1 cardinality. Bitmap is preferred. Okay, and it will be performance wise also, it will give a high performance. That's why in the definition also, can you see what is the definition for bitmap index? Bitmap indexes are created always low cardinality. Okay, now, so when you created, suppose you say, sir, on low cardinality, if I created B-tree index, what happened means performance wise slow, degrading your searching performance. Okay, now, so that's why we can go for what now? Low cardinality always prefer bitmap, high cardinality always prefer B-tree. The performance wise it will be improved. Yes or no? So now here, so less than 1. Suppose in this you can see EMP number cardinality is what now? 1. But what we said, 1 which is greater than 1, it always prefer B-tree is the best performance will give it us at the time of searching data. But if I'm creating less than 1, less than 1 means okay, 0.35. So it is comes under less than 1. So less than 1 means prefer what now? Bitmap. And bitmap indexes are first, the thing is what now? Low cardinality of columns only. Maximum people are created to improving your indexes performance. Okay, now, right. So suppose in these two columns, my job is called a 0.35. So that means now if I want to create a bitmap index, my priority column, not this, my priority column is job column. Understand now? Now, so how to create it here? Let me take syntax. So create bitmap index, and I'm giving here index name, okay, on table name of column name, table name of column name. Okay, right. So now we can see this is our syntax of to creating bitmap index here. Now, so here one note point observe. So when we created bitmap index on particular column wise, so what it was happens sir internally here observe. So when we created a bitmap index object, based on a particular column internally system is prepared or preparing a bitmap indexed table with bit numbers okay, 0 and 1. So these are called as a bit numbers. Okay now, so when we created a bitmap index object based on a particular column, internally system is preparing a bitmap indexed table with bit numbers are 0 and 1. Okay, so here what is 0 and what is 1 means? Here 0 is representing, guys, here 0 is represent what now? Condition is false. So condition is what now? False. 0 is represent condition false, and 1 is represent, guys, here. So 1 is representing what now? Condition will be true. So this is 0 and 1 means what? Okay, it means 0 means when condition is false, it returns 0. When condition true, it returns 1. Okay, right. And here every bit number, so every bit number 1 is represent row ID, in a table. So your 1 means what? 1 means what means? Your 1 is nothing but what now? Row IDs. So your 1 is nothing but your particular row ID number is represented here. 0 means condition false, nothing will be represent. 1 means condition true, and which row conditional data is true, that row ID representing what now? 1. And I said in the classes, row, okay, so your row ID is nothing but what I said, page number. If you comparing to textbook, your row IDs are nothing but what I said, page number. So same as your 1 is representing what now? Page number. Okay, your 1 is representing what now? Page number. Okay, right. So let me see. I'm going to create one bitmap index here in my database. So come out and see. So now I'm going to passing here So create, okay, which index? Bitmap, okay, index, and index name is bit1, okay, on EMP of which column? Job column I created now. So when I was created, my index is successfully created, guys. Here, the bit index name is what now? BIT1 on the column of which column? Job column. Okay. So this index is successfully we created now. Okay. But when we created index on particular column, what it was happen at the time of sending request. That means if user sending this request now, select star from EMP where job is equals to, suppose I'm sending what now? Clerk. So whenever I'm passing this request and here which condition basis are you retrieving data? Job column condition basis. And this job column, on this job column already what we created, bitmap index is already created. So that means, so that column I was taken. So that means your bit index is activated and whatever the conditional value are you given here, this is called a conditional value. So based on this conditional value, first of all, what it will do, your system, based on this column conditional value, the data will be arranged. First of all, it was arranging into which manner? Bitmap indexed table manner. Which manner? Bitmap indexed table manner. So after that bitmap indexed table is prepared as per given condition, okay, with the bit number 0, 1. And after preparing that, later your Oracle server will come to that bitmap indexed table and finding your necessary data. Finding your necessary data. So that means first what it was happening, sir, means that let me come out and see. So this query request, whenever you want to return, so immediately or internally your bitmap indexed table is created. What is the name I was given? Bit1. Bit1 or bitmap index. Otherwise, I will take bitmap indexed table is created. Okay, bitmap indexed table is created. So after created this table, okay, so on which column you design? Job column. So are you created your, okay, bitmap index on job column? Okay, now fine. In the same to same job column, can you come out and see? This is my column job, and in job column, how many rows we have here? Total 14 rows we have it here. Okay, that means the rows I'm going to taking here. Okay, so one, first row, one first row, two second row, three third row. Okay, the rows I'm going to preparing here. So 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many rows now? Total 14 rows I was given. Okay, fine. And this is my job column. And based on your job, how many values are there? That each and every value will defined as a row. Okay, fine. And after, so my condition here, job is equals to, what is my condition I was given here? Clerk. So condition value clerk. Condition value clerk. Clerk will be compared first. So clerk is equals to clerk. Clerk is equals to clerk. Condition true or false? True. Each and every value comparing. Careful observe. Clerk is equals to clerk. Condition true. Condition true means first row. True means what I said? 1. Okay. Next. Second value. Second value compare now. Clerk is equals to salesman. Clerk is equals to salesman. Condition true or false? False. So now we can come out. False means what I said? 0. Second row is 0. Next. Third row have to compare. Third row. So again, salesman. Condition true or false? False. Next condition? False. Next condition? False. 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 So 9, 10. Next true. 11th one true. 12th row true. And 14th row true. Remaining all are false. And first one true. Okay. 11, 12, 14. Is it clear? 11, 12, 14. So now just come back. So false. Next false. Next false. Okay. Next next what now? 6 also false na? Yes. 7 also false. 8 also false. 9 also false. 10 also false. 11, 12, 13, 14, true. Okay, na? So 9, 10, so 10 and 11, 12, 13 and 14. Okay, na? Right. So now we are also. So this is arrangement of a bit indexed table. After arranging here, and what I said, guys, here, wherever one is there, the one is representing what I said, row ID number in your table. And already we discussed row IDs in subqueries. Okay. Tell me, row ID is a permanent or temporary? It's a permanent ID. So now we can observe. So first it will come to you, your Oracle server, to this bitmap table. And first it will check it. First row, 1 is there. 1 means your row ID was there. So based on that row ID, directly jump to your row 7369. Okay. Because 7369 is my first row ID. Based on that row ID, it will be server will directly go to your first row in a table and pick that row from your table and sending to client application. Okay, now after data retrieval from this table, next what now? Next it will go to these remaining second row, third row. These are all are not searching because these conditions are true. So that's false. That's why these zeros are wherever zero is there. The zeros are or zero rows are not considered and not search. So that means what it was happen, first row 1 is searching the first row data pick, and immediately your server directly jump to which row? 11th row. Then 11th row pick. After that 12th row pick. Then 12th after directly jump to which row? 14th row. So that means here observe. So what it was happened, based on your bitmap index table, your server will, Oracle server will go to first row ID. So this is condition true, it will taken. After that, what happened? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So these rows are 10, up to 10. These rows are not searched. My point, careful observe. These rows are not searched. So instead of searching these rows, what it will do, as per your indexed table, as per your bitmap index table, your server directly first row to 11th row directly jump. So in between first to 11, in between rows are not searching. That means time saving now. Time saving or not? Yes. And after 11th row is pick. Okay. Next what now? 12th row will pick. 12th row will pick. Next one what happened? 13th row not searching again. So instead of searching 13th row, directly where it will go? 14th row. 14th row will be pick here. So that means total 14 rows are there. Out of 14 rows, how many rows are not searched? 11 rows are 11 10 rows are not searched. So that means wherever 0 is there, the 0 rows are not searched. So directly 1 to 1, 1 to 1. So wherever 1 is there, one row only directly take with the row ID, directly jump to your table, and that particular row ID will be taken out. Remaining zeros, wherever it is there, zeros will not searching. So that means here, how many rows reducing here? 10 rows searching time is reduced. Concept understanding na? 10 rows, okay, searching time is reduced. For example, you have a 1 lakh rows in a table. Out of 1 lakh rows, we are taking how many rows? 4 rows. That means remaining how many rows not searching? 99,996 rows are not searched. That is bitmap indexed table advantage and searching level. So now same as, for example, let me see. For example, if I was asking, when my condition is not a clerk, in place of clerk, suppose if I'm giving what now? President. If I'm giving what now? President. Okay, if I'm giving president, then observe. So job is equals to president. It means here observe what it was happened. Now job is equals to what now? President. So president will be checking here. Now check it out. Now president. Now, so in president, come to your table and take your job column. Okay. So check it out each and every row. So clerk is equals to president. Condition true or false? False. Salesman. False. Salesman. False. Manager. False. Salesman. False. 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 And true. Remaining false. Remaining false. So that means your president is which row? 9th row na? Yes, 9th row. So that means how I can design here? So 0. First row 0. Second row 0. Third row 0. Next 4th row 0. Next 5th row 0. 6th row 0. 7th row 0. 8th row 0. And 9th row 1. And 10th row 0. And 11th row 0. And 12th row 0. And next one is what now? 13th row 0. And next one 14th row 0. So 14th row 0. So that means now what happened after arranging your indexed table like this based on the condition, then Oracle server will come to this table, and what it will do it here, the zeros are not considered and not checked. Where it will go? 9th row. So 9th row, this is representing what I said, row ID. Then what happened directly based on this 9th row, it directly jump to where it is directly jump to 9th row, directly pick from your table. Okay, so that means this king before rows are not searching, the king after rows are not searching. So that means here how many searching rows will be reduces? 13 rows. Okay, if each row will take 1 second of time by Oracle server, then how many seconds will be saved? 13 seconds of time will be saved. That means entire table is no need to search. Only the based on your indexed, that based on your bitmap number. So directly the row ID will be representing. So directly it will be jump to your table and pick your data. But in your table, 1 lakh rows are there, 5 lakh rows are there. That is none of the matter. Okay, now. So this is bitmap indexed table, how to design. So based on the condition value, your data will be arranging into bitmap indexed table with the bit numbers are 1, 0. 0 means condition false, 1 means condition true, and this 1 is representing what I said, 1 is representing your row ID number. Every row ID is similar to like a page number in your textbooks. So how you know your concept is having in the so-and-so page number, then what we want to do? we are directly go to that page number. But remaining page numbers, are you searching? No. Why? Why you are not searching remaining page numbers? Because of reason, my required topic, where it is located, the page number when I knows, then why should again I want to search? Yes or no? If I know here my required topic is having in the page number 95 out of 500 page numbers, then if I know my required topic is located in page number 95, then are you searching again 1, 2, 3, 4, 5, 6? Are you searching all page numbers again? No, no. So directly we go to where? 95 page number. So 95 page number, I'm going to directly and taking my required topic. So 95 page number before, 94 page numbers, I'm not searching. 95 after, how many page numbers are there? That also I'm not searching. Okay, because of reason, I know my required topic is where it is. If where it is I know, means my target is what now? Directly I'm going to that page number. The remaining page numbers are, I don't need it to search. So time saving or not? Yes. So same to same here also, bitmap index will be work like this, and this is called a table. In this table format, your bitmap index will be arranged. That's why it is called a bitmap indexed table we called. And this table will be preparing by your system internally. After preparing, then server will go to this table and checking your data where it is you are required. Okay, now? So based on this indexed table information, again your server directly go to database table and pick your data from based on page number is nothing but row ID. Okay, now? So B tree, there I said what now? Asterisk symbol. Can you remember? Yes, B tree is representing row ID with the asterisk symbols. One asterisk means one row. Two asterisks means two rows. So asterisk is called as what I said there, row ID. So based on that asterisk is representing row ID is nothing but page number. So based on that, so 1250. How many 1250 rows are there in my table? 2 rows are there. Then how many asterisk symbols? 2 asterisk symbols. Each asterisk symbol is representing what now? One row ID. So based on that asterisk symbol is representing row ID. Based on that row ID, directly I'm going to table and pick our data. So their asterisks to representing your row IDs and bitmap index representing what now? 1. Understand now? So here 1 and their asterisk. That's it. Remaining process will be same. But their what format? Tree structure format. Parent level, root level, parent level, child. And if you want it, leave also. But leave is what I said, optional levels. Okay, now? And this is table format. Data will be saved like this, and based on your bit number 1, directly it will go to that row and pick that row from your table. And wherever zeros are there, zeros will never search. Okay, now? Right. So this is bitmap indexed, how to created and how to prepared by system. Later, how server will use this table for their searching data purpose. Okay, now? Right. So these are the 2 indexes, guys, here, which was supported in our Oracle. And these indexes, suppose you want to know it, on which type of index are you created? If I want to know, so there is one data dictionary is there. The data dictionary is called as a user underscore indexes. Okay, here observe. User underscore indexes, with the help of this data dictionary, I can see on which column, which type of index I was created. Either are you created B-tree indexa or bitmap indexa. So that I can go to know it with the help of what now? User underscore indexes data dictionary. For example, let me come out. Present. This is my EMP table. On this EMP table, I was created only one index. That index is what now? Bitmap. And what is my index name? BIT1. Now let me see. So now I want to see user underscore indexes. There are so many columns that came here, but in this so many columns, which column I need? Index name and index type. Let me call select index underscore name, comma, index underscore type. Okay, index underscore type from which table? User underscore indexes table. Okay, where table underscore name is equal. So what is my table? EMP table to execute now. When I executed here, let me see the above name is index name. What is my index name? bit1. Okay, what is index type? Which type of index this is? Bitmap. It was showing, clearly showing. So index name is bit1, index type is bitmap. Suppose if I created one more index, create index I1, okay, on EMP offer. So my table is called, my column is called as a salary column. So I was created one more index. This index is called as what? Which type of index? Simple B-tree index. So this is simple B-tree index. Okay. So now after created this B-tree index on salary column, right? And now let me call this. Okay. Let me call. So what I say, where table underscore name is equals to, what is my table? EMP to execute now. So now carefully observe. The index name is first one bit1 and index type is bitmap. Second index name is what now? I1. I1, what it was showing? Normal. Here normal is nothing but B-tree. Okay, now? And B-tree is called as what now? Default index of Oracle. So what is the Oracle default index? B-tree indexes. So B-tree index at default. Default means normal indexes. So your normal is nothing but B-tree, and bitmap means bitmap will be shown. Understand now? So this is a way you can see my index is a B-tree index or my index is a bitmap index. So that you have to find out. Your normal means B-tree. Your bitmap means bitmap only. Okay, right. And these indexes, even though I can drop, for example, I can drop I1, I drop it here. Let me come. So index successfully drop. So after dropping this, again, you have to come out and see your index is drop or not. So you have to check here. Table underscore name is equals to which name? EMP to execute now. So let me see. I1 index is dropping or not? Yes. Suppose bitmap also you want to drop, you can write drop index. What is index name? bit1. So here this is also drop. And let me call your data dictionary. Okay. So now I'm calling the data dictionary where table underscore name is equals to EMP to execute. Now tell me, is it any index on my table? No, the indexes are successfully we drop. Okay, so this is B-tree and bitmap. There are two types of indexes was supported in our Oracle. But any index, both indexes, intention is what now? Searching time should be reduced and quickly access your required row data from a table. Okay, so that is the concept of your indexes. And indexes are, I said, it's a similar to book index page in your textbooks. So in textbooks, how index pages are working, same as your database index is also working. Clear now? So this is index topic, guys, here. So the topic is over. The main notes I'm sharing to you. And after sharing, you should also do one practice examples I was given there in the material. Do practice. Okay. Right. So after that, still you have any doubt, you can ask tomorrow after practicing. Okay. Now? Right. And tomorrow I will go for one more concept. And there are 3 concepts are there to finish your SQL. So maybe this week your SQL will be completed. And then next week means when the date? What is the date of next week, guys? So maximum this week you are maybe tomorrow clusters. Tomorrow. This week your SQL part will be completed. So Monday I started your PLSQL. So maximum June 15 to 20 between your course is completed. Okay, na? June 15 to 20 between, like 17 or 18, I will finish your batch. Okay, na? Right, guys. So I stop it here and tomorrow we will continue. Okay, na? Right. Thank you. Thank you so much.